All right, Wednesday. Let's get it on. Get out your homework, please. Okay, so we had a worksheet. It was Pythagorean theorem. It was just basically more practice on Pythagorean theorem. As always, I'll post the answers. There they are. Go ahead, pause the video, check your work, and then answer question 1 on Google Forms. Okay. As always, just remember you can always pause the video, rewind, and we shouldn't come to class with unanswered questions because we got 2 days to do each homework assignment, and you can always email me for help. All right, so we're going to do 10.5 A today and 5B on Friday. It is a little bit more challenging work today. We're not going to be doing Pythagorean theorem. We'll come back to Pythagorean theorem next week, but we're going to do something different today and Friday. Quiz next Friday. Okay, here we go. Here's your homeworks from the book. Write it down, please. All right, this is also at the bottom of the Google form. All right, so we're going to do today something called similar triangles. We're not using Pythagorean theorem. We'll come back to it next week. All right, 2 objectives, something about angles and side lengths of similar triangles. So today's kind of a tough day. You got to be a smart monkey in order to get this stuff done. So the last few classes we've been dealing with right triangles, Pythagorean theorem. In previous classes we've done acute triangles and obtuse triangles. We're going to do all of them today, And we're going to do something about their angles and their side measurements. We're going to be doing a new idea. The new idea is this. For those of you that are familiar with PowerPoint or anything in basic computer programs, when you deal with objects and you click on them, like if I draw a shape in PowerPoint and I click on them, I get that kind of little box thing if you're familiar with it. And if I grab one of the corners and I drag it, I can make that triangle, the little blue one, into a larger version of itself. Okay? And in math, we have a name for this. When the shape is still the same shape, meaning it stays the same proportions, right? One side doesn't get longer and the other side gets shorter, but all the sides either increase or decrease by the same proportion. We call this a similar triangle. Similar meaning that the shape hasn't really changed; it's just simply grown or grown larger or grown smaller. Okay. All right. So this is the idea. Similar triangles are the light blue one there. If we maintain the same shape, just make it larger or smaller, we call this similar. If we take the dark blue one there and we change its shape, well, it's still a triangle, but it's a different type of triangle. Now it's a right triangle. These are not similar shapes. So similar shape has something to do with, well, it maintains something about its shape that stays the same. Now, clearly, the similar ones, they're not literally the same size. One's small and one's big, but they're versions of itself. So let's write down the actual mathematical definition. So similar figures have exactly the same shape, just simply different size, enlarged or made smaller from the original shape. So that's our math definition that we're going to work with. So it means exactly the same shape. If you have an equilateral triangle, you're still going to have an equilateral triangle once you make it larger or smaller. You don't turn it into an acute triangle, or I'm sorry, you don't turn it into a right triangle if it's equilateral. So for instance, if I have triangle ABC and I make it larger, well, we can't call it triangle ABC anymore. We got to give it a new name, so maybe DEF. And we also have a symbol to show that the two triangles are similar. So the similar symbol is, well, on computer terms, we call it the tilde, T-I-L-D-E. In math words, we call that one little wiggle, we call that a similar symbol. And here's how you would write that the two triangles are similar. You'd say triangle ABC is similar. Remember, if you put two of those little wiggly lines together, it means approximate. So it's kind of sort of same idea. In this case, though, if there's one, it means that they are similar. All right, recall the following. So if you have an equality, that means whatever number's on the left side is the same numbers on the right side. For an inequality, that's not true. Whatever's on the left side is not the same as what's on the right side. We've dealt with this symbol. That's an equality with one tilde. That's called the congruency symbol. And a congruency symbol means this. When you're comparing two parts of two different shapes, but their values are the same. For instance, this side is the same as this side, its length. Then we can't say equal because, one side of a triangle is not the same as the side of a rectangle. But we can say that the two sides are congruent, meaning that they have the same values. That's what that means. And then lastly, we have this new shape or new symbol. This is called the similar symbol, and that means that the left side is similar to the right side. Okay, in this case, the values will clearly not be the same. All right, for similar figures, it turns out that we get two consequences. Two consequences. We'll talk about them one at a time. So the first consequence is this. If I start off with two triangles that are similar, how do they know that they're similar? Well, the statement there in yellow says that they're similar. So if I have two triangles that are similar, it turns out that the angles of those polygons are congruent. In other words, that the parts that correspond to each other. So for instance, the top angle of the small one is A, the top angle of the second one is D. And therefore, we know that if they're similar, that means that they're congruent. That means that they have the same measurements. So angle A is the same as angle D. Angle B, the lower right, is the same as the lower right on the larger one. So B is congruent to E, and then lastly, C is congruent to F. Okay, so the first consequence is that if two shapes are similar, that we say that their corresponding angles are congruent. Now, how do you know that the angles are corresponding? Well, we go back to the statement there in yellow. Check it out. Look at the first letter there is A for the first triangle, and on the second one, the first letter is D. So A goes with D, B goes with E, and C goes with F. That's how you know which ones are congruent, or which ones are corresponding. If they're corresponding, then they are congruent. So we're going to play a new game here, and that's to calculate the measurements of similar triangles. Calculate the measurements of similar triangles. So I'm going to take two triangles that are similar, and I'm going to turn or twist one so that you're not really sure which angle goes with which angle. So what are you going to do? Well, you're going to rely on what's called the similarity statement. So the similarity statement there says that triangle ABC is similar to DEF. So I know that A goes with D, B goes with E, C goes with F. Does that make sense? All right, and then what I'm going to do is I'm going to tell you some measurements. So remember the little m there that it says angle A, that means the measurement of angle A is 60 degrees. I'm also going to tell you that the measurement of angle C is 70 degrees, and then I'm going to ask you one question. What's the measurement of angle E? Well, A and C are on one triangle and E is on the third triangle. How in the world are we going to do that? So in other words, how big is that one when I'm not even told how big D and F is? And what we're going to rely on is the fact that if we know the two triangles are similar, that means their corresponding parts are congruent. So the first letter with the first letter, the middle letter with the middle letter, the last letter with the last letter. So if we know that angle A is 60, well, angle A corresponds to angle D, the first letter with the first letter, A with D. So therefore, if A is 60, right, therefore D must be 60. Okay, we know that if C is equal to 70, well, C corresponds with F. So if C is 70, then F has to be 70. So to find angle E, let me mark that. So to find angle E, well, I would need to know that it's congruent to angle B, and I don't know what angle B is. But we're going to use one other bit of information. We know it's a triangle. So how many degrees for the interior angles of a triangle from a couple chapters ago? We know that if we add up all the angles of a triangle, you will always get, anyone? 180 degrees. 180 degrees. So if we want to find what E is, well, we know that E would be, I don't know, well, it's got to be whatever's left over if the interior angles add up to 180. Well, we know two of them. D and F add up to 70. So D and F would be, let's see, 60 and 70 is 130, and 180 minus 130 is 50 degrees. So how did I get that once again? There's the math there, but I'm using the fact that all three angles must add up to 180 degrees. I find two of them, and then I subtract their sum from 180 degrees. Does that make sense? Yeah, that's a pretty tough one. How about we do one together? All right, so once again, we're going to have two triangles that are similar. They're going to give you two of the angles, and they're going to leave off a third. Okay, so the first thing you do is just simply label what you got. Well, we know that angle A is... we're trying to find angle F, right? Angle A is 40, and A goes with, I'm looking at my similarity statement, A goes with D, so therefore D is 40. I could label that. We know that B, look at my similarity statement, B goes with E, and if B is 50, then E is 50. Let me label that. To find the last one, f, we simply add up the other two. 50 plus 40 is 90, and we subtract that from 180. Okay, so 50 plus 40 is 90, 90 or 180 minus 90 is 90 degrees, so therefore f is 90 degrees. Okay, so for those of you like, okay, got it, that wasn't that bad, go ahead and do the next one. Okay, this is question number 2 in the Google Forms. Go ahead and answer that. Pause the video. All right, do one more. Do one more. This is question, let's see, 3 on the Google Forms. Okay, so let's see. Angle A goes with D. We're trying to find angle C. So D is, A is 40. We know the E is 55, and E goes with, I'm looking at my similarity statement, E goes with B. So therefore, let's see, B would be 55. Therefore, let's see, 40, I'm trying to find C. So 40 and 55 is 95, and 180 minus 95 is 85. So C is 85. Make sense? Okay. All right, one other thing we're going to do. So it says calculate the angle measurements of similar triangles. So this is where are the triangles? So this is actually what, 2 triangles? You see the small one? The small one is, well, I should say the large one is ABC and the small one is ADE. Right? And we're told that ABC is similar to AD. So this is the same type of problem. They just have nested parentheses, one inside of the other one. Okay, so let's see. Let's label what we got here. So we know that angle A is 15. Angle A is on both triangles, right? We're trying to find the measure of ADE, find the measure of ABC and ADE. So let's trace that with our finger. Let's see. We can label A as 15 degrees. Okay, that one's done. Let's see. Well, we know that, let's see, I'm going to look at the small triangle first. We know that ADE is a right triangle. We also know that ABC is a right triangle. Therefore, we actually know 2 of the 3 angles. Angle C and angle E are 90 degrees. Okay, so if we look at the big triangle, because we're trying to find ABC, the big triangle, that would be 15 and 90, right? Where am I getting that from? Because remember, those square means 90 degrees. So let's see. ABC would be 180 minus 15 plus 90. Where am I getting that from? The square is 90, and we know the angle A is 15. 90 and 15 is 105, and 180 minus 105 is 75. Okay, well, that one's done. Now, we could do the math, or we could just realize that B, and that is angle ABC, corresponds with the angle ADE, right? So ABC, or angle B, corresponds with the angle D. Therefore, if I know what B is, then I know what D is as well. Or I could do the math as well, too. It would be the same math, by the way. So since B corresponds with D, then therefore AD is also 75 degrees. That one's a little bit tricky, okay? Okay. All right. Let's see. The second one we're going to do is a little bit more challenging. So I remember I said 2 consequences. So the first consequence is that if you have 2 similar figures, then the corresponding angles are congruent. So this is the more tougher one. And the second one, let's just write this down, is that similar polygons maintain proportional side lengths. That means their sides are in a proportion. So corresponding sides are in proportion. So if we're given that triangle ABC is congruent to triangle DEF, that means that their side lengths are going to be in proportion. So well, how do you find their corresponding sides? So when we're set up like this, it's not hard. I mean, left side with left side, right side with right side, bottom with bottom. But we can also get that from the similarity statement. Check it out. A side length would need 2 letters. So look at it in yellow there. The first 2 letters are A and B. Right, on the yellow. So if we go A and B, well, that would correspond with the second one. So AB would correspond to DE. And remember, side lengths of polygons are segments. So segment AB corresponds to segment DE. Take the next 2 letters, BC. So BC would correspond with EF. I'm just getting that all from the yellow. Now, I could get it from the picture as well, too, but trust me, we're going to flip the pictures around, and it's going to be confusing. So go with the yellow the similarity statement. Lastly, let's see. CA would go with FD, okay? And I could have said AC and DF, either one. Now, those are the corresponding sides, and it says that the sides are proportion. So that means take any two sides. So for instance, AB, well, AB goes with DE. So AB over DE equals BC over EF equals CA over FD. See where I'm getting that from? So AB, which corresponds to DE, so AB over DE equals BC over EF equals CA over FD. That's the pattern. So in yellow there, that last part that I just showed you is what you need to use in order to get the answers for today. So don't panic yet, right? Copy this down, pause it if you need to. Don't panic yet, but we're going to use that last statement there to get to an answer. So here's what it's going to look like. I'm going to give you two similar triangles. It's going to tell you that they're similar. And one of the sides is going to be missing. Check it out. On the larger triangle, there's an X there. We don't know its length. So here's how this is done. Okay, step number one is you're going to make a proportion. Okay, so for instance, well, a proportion is a fraction equal to another fraction, correct? So what we're going to do is we're going to find the unknown side. So the unknown side is x, right? So we're going to put that on. You can put it anywhere you want. I just find it easier to since it's what I'm trying to solve, I always put it as the first one. It could be the last one, but it doesn't make a difference. I put it as the first one because I just want to use it initially so that I can make sure I don't leave it off. So look at the two triangles. What does side x go with on the smaller triangle? So on the smaller triangle, find its buddy, right? On the smaller triangle, x goes with 8. So put 8 on the bottom. So let's see, I've got large side over small side. So, or I should say, the side of the large triangle over the side, that's corresponding side of the smaller triangle. So x goes with 8. And then the magic of this is you pick any other side on the large triangle. So it doesn't matter. Go back to the starting triangle and find any known side and its buddy. So for instance, I could pick 18 or I could pick 15. I'm just going to pick 15. The smaller the number, the easier the math. All right, so I'm going to pick 15. So 15 goes on the top and its buddy is 5. See where I got all that from? So x is what we're looking for. So x and its buddy is 8. So x over 8. I go back to the triangle that I started with, which was the large one. I pick either side, 18 or 15. Either one will work. Smaller number, the easier the math. And then I pick its buddy, so 15 over 5. Okay? And then I simply solve that proportion. Remember, we solve proportion using cross multiplication. So let's see, 5 times x is equal to 15 times 8. So 5 times x is equal to 15 times 8. I'm just doing cross multiplication there. 5 times x, or x times 5, is equal to 8 times 15, or 15 times 8. And then I simply do the math. 8 times 15 is 120. Divide both sides by 5, and I get x is equal to 24. I think we need to see that one again. All right, two other triangles, they're similar, and we're asked to find the unknown side. So step number one, we make our proportion. We find the unknown side. The unknown side is x, right? The unknown side is x. What's its buddy, or what's its corresponding side? Its corresponding side is 3, right? So x over 3, and then we go back to the original triangle. Always go back to the original triangle and pick either side. I could pick, 6 or 12. Obviously, I'm going to go for the smaller number, so the math is a little bit easier. So 6 and 2, so 6 over 2. To solve for x, we simply cross multiply. 2 times x is equal to 6 times 3. 2 times x is equal to... You're tracking what I'm doing here? Pause the video, rewind if you need to hear that again. 6 times 3 is 18. Divide both sides by 2. So x equals 9. Okay, if we're going too fast, rewind, rewind, rewind. All right, let's do this one together. For those of you who know what you're doing, go ahead and pause. Now, I've specifically made this one tricky. This second triangle has been turned and twisted, okay? All right, so if we were to match up the two triangles, let's say the large one to the small one, we would have to take the large one, we would have to rotate it and flip it, okay? We have to rotate that one and flip it. So when we make our proportion, well, I can see where x is, but which side corresponds with x? Is it 4 or is it 5? Well, you got to be able to do this in your brain, like flip the two triangles around. So if I rotated that, just rotated the larger one, it wouldn't match the other one. I would actually have to flip it. So side x actually goes with the side length of 4. Can you see that flip that goes with the twisting? I'd have to twist it and flip, or rotate and flipped. Okay, then I can pick any other side of the large one. Obviously, I'm going to pick the smaller of the two, 12. I could pick 30. Let's see, what side does 12 go with? 12 goes with 2. So 12 over 2. So this was the more challenging one because you have to mess this around, or flip it around in your head. So let's see, 2 times x is equal to 12 times 4, 4 times 12. 4 times 12 is 48. Divide both sides by 2, and we get 24. All right, I got some smarty pants out there, and the smarty pants are probably saying this. I don't need to cross multiply because I can just see that one side is doubled or tripled or quadrupled, something like that. Well, yeah, that does work sometimes, but other times that doesn't always work. Okay, so check this one out. When we make our proportion, well, where's x? There's x. X would go with what? X would go with 11, right? And then when we go back to the original triangle, 3, 3, well, I can't tell whether it's doubled or tripled. How do I turn 3 into 4? All right, it's not an easy matter there. So there are occasions here where you literally have to do some cross multiplication. So 4 times x equals 3 times 11. That's 33. And you will get a really ugly answer here. When we divide both sides by 4, you get 8.25. Okay? All right, so go ahead and do this one all by yourself. Go ahead and pause the video. And if you need a hint, go ahead and play a hint. But try to do the whole thing by yourself and answer the next question on Google. I believe this is the last question on Google Forms. Okay, so let's see. The unknown side is x. X would go with 3. And then I go back, oh, both sides are 49, so I got to choose 49, unfortunately. So 49 over 7. We multiply them together. Let's see, 7 times x is equal to 3 times 49. 3 times 49, 27, carry 2, 12, 147. And we divide 7 into 147. That would be what, 21? Yeah, there we go, 21. Okay. For those you need to review that, play that last part of the video again. The proportional sides are the more challenging one. It also does require you to flip some triangles around in your head. That can be challenging as well too. All right, if you have any questions, make sure you email me. But with that, we'll conclude class, and I will see you guys on Friday.